Okay, this is section 5.5. This is number 29. And we're doing the tangent. I drew a little sketch of the tangent over here so you could take a look at it. And realize that the period of the tangent is just pi, not 2 pi, if you forgot that. Okay? And here we're looking at this interval from 0 to 2 pi. So we're going to actually get 2 periods of the tangent in its normal form, although it's not going to be just in its normal form in this problem. Okay? And since we're starting at 0, it could look something like that. That could be 1 period, where it just goes up and then from the bottom. Okay? But you can still see over that 1 period, you only have 1 solution. Okay, so we've got the tangent of 3x. So remember the period. Now for the tangent is not 2 pi, but just pi over b, which is going to be pi over, and the number in front of the x is 3, so just pi over 3. So it's going to be pi over 3. Now that means I have a period just 1 in pi over 3, and now I've got going from 0 to 2 pi, so I'm going to go pi over 3, pi over 3, pi over 3 is 1 pi and another 3. So actually I have 6 pi over 3 over 6 pi over 3 is 2 pi. So I'm going to actually have 6 solutions for this, because this is going to repeat itself like this 6 times to get to 2 pi. Because it's going to repeat itself once in pi over 3, then 2 pi over 3, then 3 pi over 3, 4 pi over 3. So 6 times, so I have 6 different roots. So that's what we're going to be dealing with. So let's get on with it. So if we look at the tangent of 3x, we know that 3 times something, so we'll bracket it like that. So 3x, 3 times something equals. And now remember that this is the same thing, the square root of 3 over 2. It's just a rationalized form of 1 over the square root of 3. That's usually how we kind of remember for the unit circle. We don't usually rationalize it, but here you can rationalize. If you rationalize it, you get this. This basically is telling me that the 3x equals, and the tangent of what angle is 1 over the square root of 3? Pi over 6. Okay? But that's 1x, so I want to find, that's 3x, so I want to find out what 1x is, so I'll multiply by 1/3. It's a little bit easier way to do it. And I end up with x equals pi over 18. Okay? So that's my first solution for this value of x is pi over 18. Okay? In other words, it's pi over 18. It's going to be equal to the square root of 3 over 3. Now, all we do is just keep adding periods of that till we get past 2 pi. Okay? Now, this is pi over 3, but we're going to be in 18, so if I multiply the top and the bottom by 6, I would get pi over 3. So this is the same thing as 6 pi over 18. Is that pi over 3? Yep. So that's the length of a period. So I just keep adding that to this till I get past 2 pi. So it's not too hard once you get a grip on things intuitively. Okay? So if I add 6, I get 7 pi over 18. And then if I add 6 more, I get, because you just have to add the one period, because remember, because it's the period is pi and it's symmetrical, you just keep, every time you add a period, you get to the next value, and you don't have to do 2 values like cosine or sine, because the period is just pi. Okay? So if I add 6 to 7, what do I get? 13. I think you can do that over 18. And if I add, now what do I have to get 2 pi? It has to be 18 over 18. I'm sorry, 36 over 18. So I got a ways to go yet, so I can add another 6. I get what, 19 pi over 18. And I can add another 6, I get 25 pi over 18. Add another 6, I get what? 31 pi over 18. And then if I add one more, I get 37, and that's greater than 2, because 36 over 18 pi equals 2 pi. So I just want to keep it under 36. So there you go. So there's your solution. And it's already in order, so that's a nice thing, so it wasn't too bad. So there's your answer. That's all you got to do. So if that makes sense, it's not too bad. You just have to realize what the period is, how to find it, and not too terribly difficult. Okay, now let's take a look at number 31. And 31 is the tangent of x over 2. All right? And the same thing, we got our same domain, 0 to 2 pi. And this is the same thing as the tangent of 1/2 x. So my period is equal to pi over b, so pi over 1/2. Which is the same thing as if I invert and multiply 2 pi. So that's nice because my period is 2 pi. That means I'm only going to have one root because I only have one root for a complete period. So that's nice. Okay? Oops, forgot to add what it is equal to. Okay, I was so anxious to get that. That's going to equal the square root of 3. Okay? So the tangent of something is equal to the square root of 3. Well, that something would be what? The tangent of something equals the square root of 3. And what angle is that? That would be pi over 3. Okay, because 1 over the square root of 3 is pi over 6. So the square root of 3 is pi over 3. So if I want to find out what x is, I just multiply both sides by 2. So x equals 2 pi over 3. Okay? And that's my solution. Now, if I add a period to that 2 pi, I'm out of the domain, so I'm done. That was nice. That's the only solution. Alrighty? Let's try another one. Number 33. And this is going to be the sine of 2 theta all over 3 equals -1. Now we're back to a period of 2 pi for the normal period. So again, we're on this 0 to 2 pi restricted domain. And remember, this is the same thing as 2/3 times theta, so b equals 2/3, so the period equals 2 pi over b, or 2 pi over 2/3. All right, so that's my period. Remember, period equals 2 pi over b, and that's like 2/3 times theta. So period equals, so if we invert and multiply, we've got 2 pi times 3 over 2. Okay, so that means that the period is going to be 3 pi. Okay. Now, I'm not too sure if I'm going to have even a solution in here. I'm going to have to check it because my domain is 2 pi, so my period is going over that, so the solution might be out of there. But remember, on the sign, we do have two possibilities. So maybe one of those will be in there, maybe both will be in, so let's check that out. All right, so the value of what, the sign of what is equal to -1. Now, this is one of those ones where there's only a single value again also, so that kind of restricts it again. So we may not have a lot of solutions on this. Okay. So this is one of those like negative ones, so we know that's normally it's just going to be -3 pi over 2. I'm sorry, 3 pi over 2. That's our normal. Okay. It's equal to -1 at, well, actually, that's the normal is 3 pi over 2. This is 3 pi over 4, but that's a different period. So we have to look at this one over here. Yeah, here's the same. So there's 2 pi, so there's 3 pi over 2. So that's the one I should have used. So I know that's 2 theta over 3. Okay. Okay, there's something, the sign of this something equals -1 when that something is 3 pi. I'm sorry, 3 pi over 2. Okay, 3 pi over 2. Okay. So the sine of 3 pi over 2 equals -1. Sine of 2 theta equals -1, so 2/3 theta, pardon me. Let's try this again. The sine of 2/3 theta equals -1, and the sine of 3 pi over 2 equals -1, so these must be equal. Now, how can I find out what theta is? Well, I can multiply both sides, so theta equals 3 pi over 2 times 3 over 2. And that ends up equaling 9 pi over 4. Okay? And that's the only time I don't even have two solutions in this case, because remember, normally we have two solutions except for at pi over 2 and 3 pi over 2. And that's going to be 1 and negative 1. So we only have one possibility. So this is my one possibility. But notice something about this. 8 pi over 4 equals 2 pi. So the only solution I have is actually outside my domain. This is the only solution I have because there's only one solution for this negative 1 normally, and in that domain this doesn't happen there. And you could graph it, and you could see what happens is it's actually equal to negative 1 outside this domain, so no solution. Okay? And I can show you that on a graphic calculator, but because let's see, the period is 3 pi. Yeah, it's a little hard to graph that because it's asymmetrical. Okay? But maybe I'll just show you on the calculator on the next video, so you can maybe appreciate that. Okay? So this is out of the domain. Okay? But it's easy to graph on the calculator, so I'll show you that on the next video. Okay? So on 35, I'll start with this one.